My YouTube channel today. If you are a student preparing for WAEC, subscribe to this channel. If you are preparing for JAMB, subscribe to this channel. If you are preparing for post-UTME exam, subscribe to this channel. Now, in today's video lesson, we are going to be looking at what? Acid-base what? Reaction. Okay? If today is your first time for coming across this YouTube channel, you are welcome to my YouTube channel. In this channel, you are going to be learning mathematics, you'll be learning physics as well as what? Chemistry. So if mathematics, physics or chemistry is your problem, then you have no problem as long as you are in this world channel. Now, what do we have to do today? We are talking about acid-base what? Reaction. Okay, a reaction between acid and base is called what? Neutralization what? Reaction. Don't forget that neutralization reaction is a reaction between an acid and a base to form what? Salt and water only. Okay, now when we are solving problems involving acid-base reaction, there are two main cases that you have to consider. What are the cases? Case number one, when an acid reacts with a base. Now, the product will be salt and water. Do you get? So, if I have an acid like H2SO4 reacting with a base, which is sodium hydroxide, it will give us salt and what? Water. Now, there's also another case, which is called case 2, when an acid reacts with metallic triisocarbonate 4, as you can see on the board. So, if an acid reacts with metallic triisocarbonate 4, you must understand that what a base can do, metallic triisocarbonate 4 can also do, in the sense that your base can neutralize an acid to form salt and water. Metallic triisocarbonate 4 can also neutralize an acid to form salt and water plus what? Carbon dioxide. So let's take a case of this metallic triisocarbonate 4. If we have tetraoxosulfuric acid with calcium triisocarbonate 4, this one is functioning as the what now? As the base in the what? Reaction. So if we have a base plus an acid to give you salt and water, but whenever you have metallic triisocarbonate 4, such as the one you are seeing here, it will give you salt, water plus what? Carbon dioxide. So there are cases in acid-base reaction where you will be told to calculate for the volume of the gas involved at STP. So that must be in the case of your metallic triisocarbonate 4. Now, if you are solving problems involving acid-base reaction, there are some basic formulas that you need to memorize. What are the formulas? Look at the board. There is a formula here that says CaVa all over CbVb is equals to Na over what? Nb. Now, what does that mean? Our Ca is concentration of what? Of your acid in what? In mole per dm cube. Now, don't forget that concentration in mole per dm cube is also called molarity. So this is the molarity of the word acid. So if I have Cb, it is called concentration of what? Of B, which is the concentration of the word of the base in what? In mole per weighting per dm cube. Are we together? So it must be noted that Cb and Ca stands for the molarity of the acid and the what? Base. Then if I have Va is known as the volume of what? A in what? Cnp. Okay, Vb is known as the volume of B in what? Cnq. Please, it must be noted. More also, what does Na and Nb signify? Your Na is number of moles of A. Take note of that. That's the numbers of moles of the acid. Now, if you look at the equation on the board, you will see that H2SO4 has 1 mole. So in this reaction, Na is equals to 1. While your base, Nb is equals to what? 2. Are you seeing it now? So this is your H2SO4, this is your what? Your sodium hydroxide, which is your base. So you have 2 moles here, but here you have moles. Mole simply means the coefficient of the species. So as you can see on the board, the coefficient here is what? 1. But the coefficient here is what? 2. So this is 1 mole, this is 2 mole. Let's talk about this one. The coefficient here is 1, which is 1 mole. This one is also 1 mole. So here, Na is equals to 1, and what? Nb is equals to what? 1. So Na and Nb signifies the numbers of moles of A and what? And B. More also, the second important formula involving acid-base reaction is your C and your rho. Remember in my previous video lesson where I told you how to do calculation involving concentration, I made use of this important formula. And I told you that this formula is the concentration of a substance in mole per dm cube. And this guy, as long as it's in mole per dm cube, is also called molarity. Okay? Then this is called the concentration of the substance in what? Gram per dm cube. That is to say, this guy is mass concentration. Yeah. While this is your weighting at molar mass. So we can say that capital letter M is the weighting, the molar mass. Okay, now we are going to take questions involving acid-base reaction. Let's take few questions on this topic. Question: what volume of a 0.1 molarity, that's concentration in mole per dm cube, H3PO4, this is the acid, is called tetraoxophosphate 5 acid? Okay, so if this is the concentration of the acid, what volume, we're looking for the volume of the acid having this concentration, H3PO4 is the acid, will be what? Required, okay, to neutralize 45 cm cube of a 0.2 molarity sodium hydroxide. So the volume of the base is 45 and the concentration of the base is what? 0.2 molarity. Now, what do we have to do first? The first thing to do is to write the chemistry of the reaction so as to determine the number of moles of acid and base respectively. So what do? We'll begin by writing the chemistry of the reaction. The chemistry of the reaction having H3PO4, okay, plus sodium hydroxide will give us salt and water. So you have Na3PO4 plus H2O. So what do we do now to balance the equation? As you can see, you have Na3PO4. So that means we are going to have 3 here so that the sodium becomes what? 3. Okay. Then you have PO4. The hydrogen is 3 here, then another 3 here, making it what? 6. So we add 3 here. So the hydrogen becomes what? 6. Okay. So we have PO4. The PO4 and the PO4 is balanced. Okay. The sodium and the sodium is also what? Balanced. So we are left with the number of hydrogen and oxygen. So you have 3 hydrogen here, making it what? 6. So you have 6 hydrogen here. More so, you are left with 3 atoms of oxygen, which is 3 here. So the equation is what? Balance. So because of that, this is the acid. You have 1 mole of the acid. This is the base. You have 3 moles of the base. So now let's go back to the equation. After balancing the equation, they say we should calculate for the volume of the acid. So Va is what? Unknown. They gave us the concentration of the acid. Ca is 0.1 mole per what? Dm cube. Don't forget I told you mole per dm is something as molarity, so that's what you have here. Then to neutralize this volume of the base, volume of the base is 45.0 cm cube. Then this is the concentration of the base, which is what? Cb equals to 0.2 mole per what? Per dm cube. More also, the number of moles of the acid, look at it on the board, 1. So Na is equals to 1. Number of moles of the base, Nb, is equals to what? 3. So what's our formula? Don't forget, CaVa all over CbVb is equals to Na over what? Nb. So what's Ca? concentration of the acid. So you have 0.1. What is Va? We don't know, so write Va all over Cb. What is Cb? 45. What's the volume of the base? Sorry, Cb is 0.2 times volume of the base 45 equals to Na, number of moles of the acid 1, number of moles of the base now waiting 3. So what do we do now? Very easy. We have 0.1 Va over 0.2 times 45. So 0.2 times 45 will give us 9 equals to 1 over 3. So what do we do now? We cross multiply. If we cross multiply, we have 3 to multiply this. So you have 0.3 Va equals to 9 to multiply this, you have 9. So we divide both sides by 0.3, divide by 0.3. So this cancel this. Our Va, which is the volume of A, will be 9 over 0.3. So Va will give us 30. So you have 30 words cm³ of the word acid. So you begin by writing the equation for the reaction, then you deploy the values given to you in the option to get your answer. So watch very well. It's not 10, it is not 20, it is not this. The answer is what? 30 words cm³. So let's take another question. Now let's take question number 2. Okay, now this is another phase of the same topic, acid-base what? Reaction. So how do we solve this question? Now let's look at it carefully. 2.0 gram of a monobasic acid, okay, was made up of 250 cm³ with distilled water. Do you understand? Now they took 2.0 gram of the monobasic acid and they dissolve it in a solution that is made up to 250 cm³. Do you understand? So they were trying to prepare the concentration of the word monobasic acid. That was what they were trying to do. But what did they not do? When they were done doing it, they now took what? 25 cm³ from it. After preparing the solution, they took 25 cm³ of this solution. Required what? Required 20.0 cm³ of 0.1 molarity of what? Sodium hydroxide solution for complete neutralization. What does that mean? They told us how to prepare the acid, and when they were done preparing the acid, they now took 25 cm³ from the acid to neutralize the base. But here's the problem. The question says that we should calculate what? The molar mass of the acid is what? What is the molar mass of the acid? Wow. This question, if you come across this question in your exam, how will you solve it? Very easy. Remember that if I have a monobasic acid, okay, that means an acid that has one hydrogen atom and is to react with a base. Let's look at this base carefully. The base is sodium hydroxide. Now, if you watch very well, this base is also what? Monoacidic. It's monoacidic, meaning it contains one hydroxide. So if acid contains one hydroxide and base contains one hydroxide, it means say the ratio of the number of moles of acid to the ratio of number of moles of base will be 1:1. We don't need to write the equation for the reaction. It will be 1:1. So let us do that first. We'll write Na is equals to 1. And Nb is also equals to what? 1. Why is it like that? Because the acid is monobasic and the base is what? Monobasic. Okay, now look at the question. Let's leave the mass of the acid and let us leave the volume that the mass of the acid was dissolved into, which is what? 250 cm³. Okay, because that does not define the base of the reaction. What they actually used was that they took from it, they took 25 from what they have prepared. So that's what I mean the what? The reaction. So we have volume of the base equals to 25 cm³. Please let me ask a simple question. Was the concentration of the base given to us? Of the acid, volume of the acid, they took 25 cm³. Was the concentration of the acid given to us? No. So we write concentration of the acid is unknown. Do you understand? Yes, it is monobasic acid. They gave us the volume that went for the reaction, but they don't give us a concentration of the acid, and that is where we need to tackle it from. So if you look very well, you find out that everything about the base was given to us, which is sodium hydroxide. They gave us what? The volume of the base. Volume of the base is equals to weight now 20 cm cube. Okay, so what is the concentration of the base? It is equals to 0.1 molarity. Don't forget, molarity is concentration in what? Mole per dm cube. So let us solve this question. Let's begin by calculating the concentration of the acid in mole per dm cube using our formula. So we have CaVa all over CbVb is equals to weighting Na over weighting Nb. So wetin be Ca? We don't know what Ca is, so let's leave it. Ca times, what's the volume of Ca? It is what? 25 all over. We are not using 250. It was used to prepare the solution, but the one they took from 250 was 25. So that's why we're using 25. So what's Cb? Volume of the base is what? 20. Concentration of the base is what? 0.1 equals to, I told you monobasic and monobasic base, you have 1 over 1. Wow, that's interesting. So let's solve the question. 25 times Ca will give us what? 25 Ca all over 20 times 0.1 will give us weighting 2 equals to weighting 1 over 1. So what do we do now? Very easy. So we have cross multiply. 25 Ca is equals to what? 2. So we divide both sides by weighting now 25. This we cancel this Ca. Let's quickly divide 2 over what? 25. Good. So we have 2 over what? 25. That will give us 0.08 mole per what? dm cube. This is the concentration of what? The acid. Good. So this is our Ca. Do you understand? Now, they said we should calculate for the molar mass of the what? Of the acid. So what do we do? Very easy. Very what? Easy. Remember there's one video I did on mole concept. In that mole concept, I told you how you can calculate for mass or molar mass from concentration and volume given. Yes. Remember that number of moles. Yeah. Number of moles. In terms of concentration, number of moles is equals to Cv over 1000. Please let this formula sink into your what? Your score. The number of moles of any substance is the concentration in mole per dm cube multiplied by the volume in cm cube over the what? Molar mass. More also, recall that this number of moles, is also equals to reacting mass over molar mass. This reacting mass means the mass that dissolves over the molar mass. So if we combine this and this, what do we have? If you combine these two, you go get weighting mass over molar mass is equals to Cv over weighting over 1000. Is clear? Now, let's solve this question. What is the mass? The mass was given to us as weighting 2. We are looking for weighting molar mass equals to. Did we know the concentration of A? Yes, we have calculated it. See here. It is 0.08 times what is the volume of A? See 250. That's what they use in preparing it. So you have 250 over weighting 1000. So what do we do? Very easy. We go cross multiply. But before then, let's multiply this by this to make our values easier. So if we divide 0.08 by, if we multiply 0.08 by 250, you have 20. So that you have 2 over n is equals to 20 over 1000. So what do we do? I think we have to cross multiply. 20 times n, 20n equals to 2 times what? 1000. Okay? I think we divide both sides by weighting 20 divided by what? 20. So this cancel this. Our what? Our molar mass will be equals to 2 times 1000. It is 2000. Divide them by weighting 20. 0 cancel 0. 2 go into 200. You have 100 weighting grams. That's the molar mass of the word acid. So the option is not A, it is not B, it is weighting this C. We have 2 more questions on different phases involving acid-base reaction. Now let's take the third question. Look at this third question. Na2CO3, that's metallic triacyl carbonate 4, reacted with HCl and it gave us salt, water, and weighting carbon 4 oxide, like I told you. Using this equation, what is the volume of carbon dioxide measured at what? STP liberated when 53 grams of sodium carbonate is dissolved in the what? In HCl. Very easy. What do we have to do? Let's bring out the equation for the reaction again. So we have Na2CO3 plus 2 moles of HCl will give us weighting NaCl plus H2O plus what? CO2. I guess the equation is what? Is balanced, okay? Now let's look at this question very well. Wow, this is interesting because the question wants us to focus on the mass of this that we produce carbon dioxide. Check it out again. Look at it. They said using the equation, what is the volume of carbon dioxide measured at STP? Look at the board. Just look at the board. At STP is what? Liberated when 53 grams. So they gave us the mass of this guy. Mass. You understand? So, but they want us to calculate for the volume of what? Carbon dioxide. So we are looking for a volume here. Now, if this question happens to be in a topic called stoichiometry, we would have said that this problem is mass to volume what? Relationship. But the first thing we are going to do is to calculate for the molar mass of this guy before using the values in the question. So what's the molar mass of? Molar mass of Na2CO3. Let's do that quickly. You have Na is what? 23 times what? 2. Carbon is what? 12. Oxygen is what? 16. Okay? 16 times what? 3. So you have 46 plus 12 plus 3 times 3 is what? 48. So you have 106 grams per what? Per mole. So the molar mass of Na2CO3 is what? 106 grams. So now we are going to compare this to the volume. Remember that if you look at this, you see just 1 mole. So we have 1 mole of carbon dioxide that is liberated in this reaction. And you know that 1 mole is equivalent to 22.4 dm cube. That's what they said. They said 1 mole of the gas at STP is 22.4. So according to this now, look at it. 106 grams of this Na2CO3, NaCO3, liberated 1 volume of what? CO2, which is the same as what? 22.4 dm cube. That's the first thing to do. Now, the question has said that we should determine the volume of carbon dioxide at STP that will be produced from 53 grams of the what? Sodium bicarbonate. So you have 53 grams here will give us weighting X volume in what? In dm cube. So what do you think we should do? We'll simply just cross multiply. So when we cross multiply, we have X times 106. 106 weighting X. Then you have 53 times what? 22.4. So divide both sides by 106. Divided by what? 106. So this cancel this X, which will be the volume of carbon dioxide evolved at STP, will be this times this divided by this. Let's do that quickly. If you multiply your 53 times 22.4 over, you have 11.2 what? dm cube. So that's the volume of the gas evolved at STP, okay? Now, so the answer is not A, but the answer is what? B. We have just one more question. Please stay to the end of this video because this question is very tricky, the one we want to consider right now. Now, let's solve this question. Now, fortunately, this question happens to be the hardest of all the questions, okay? Now, but if you can solve this question, it's a sign that you are actually good at chemistry. Yeah. Now, watch this question. The question says 1.0 gram of CaCO3 was treated with what? Excess HCl. So the HCl was in excess to the point that at the end of the reaction, the acid still left unreacted went and what? Required 25 cm cube of 0.1 molarity Na2CO3 to neutralize it. Wow. What was the original volume of the acid? Very easy. If you come across this question in your exam, how will you solve it? Very easy. Now, calculate for the volume that reacted with CaCO3 and also calculate for the volume that reacted with NaCO3. Add it up together. That becomes the answer. But it is interesting for you to know that for CaCO3, the concentration was not given. So we don't have to go in the order of what? Concentration. Okay? Yeah. But this is what we have to do, and that is very, very important. Okay? To do now. Let's solve the question. Now let's go carefully. We'll begin with the first reaction. The first reaction, please watch very well. Now, this is ACl and this is Calco 3. Don't forget we're looking for the volume of what? ACl. Is that clear? Yes. Now watch. According to the first equation, we have 2 moles of ACl. Please watch me carefully. Require how many moles of Calco 3? 1 mole, as it is given to us here. Okay, so we don't know the number of moles that is going to react with the Calco 3 because they gave us the mass. Look at the mass of Calco 3. So let's calculate for number of moles here so we can put it here. Okay, so you have number of moles of CaCO3. Let's do that quickly. Don't forget that number of moles equals to mass over what? Molar mass. And the mass that they gave us here, 1. So you have 1. Molar mass of Calco 3 they gave us as what? 100. So you have over 100. And that will give us 0.01 mole. Are we together? Yes. So as I don't get the number of moles now of Calco 3, I will put them here 0.01 mole. So what I call do now to know the number of moles of the ACl